Hello, everyone, and welcome to the latest edition of our podcast interview series. So as always, we want to make these sessions interesting and interactive. So please do introduce yourself. Tell us where you're joining from and what you do. And of course, as always, please feel free to add your questions to this conversation. And feel free to answer each other's questions as long as they're relevant. So before I have the immense pleasure of introducing today's guest, I want to go over a few announcements. So, as you may know, we just wrapped up ODSC East last week. Fantastic conference. So great to meet so many people there. As always, the keynotes and especially our speakers and our instructors, and certainly including today's guest in that, were absolutely excellent. I was looking at the ratings we got from all those sessions and some of the feedback, and always one or two duds, but for the most part, fantastic sessions there. And again, huge credit to all the instructors and speakers who came to ODSC and devoted so much of their time to giving those presentations. And but the year is not over for us. In fact, it's just getting started. We have ODSC Europe coming up. We have ODSC West. We have ODSC APAC. And ODSC Europe, we switched from the summer now to the first week in September. If you've never been to London, this is your time to come. We'll be in West London, not too far from Harrods and all those fantastic places in Hyde Park. So if you have a chance, go check that out. And if you can't join us virtually, snag a free pass. And as mentioned, super excited about ODSC West in beautiful Burlingame, which is south of San Francisco. Really excited for that because, as you know, the West Coast is the hub of the AI boom, and Burlingame, right between San Francisco and Silicon Valley, is right at the heart of it. So we have lots of startups and research presenters presenting there. But having said all that, let's get on with today's show. So again, as mentioned, immensely excited to be introducing today's guest, which is none other than Dr. John Krohn, who is co-founder and chief scientist at the machine learning company Nebula. He authored the book Deep Learning Illustrated, which was an instant #1 bestseller and translated into 7 languages. 8 must be coming soon. He's also the host of the absolutely fabulous SuperDataScience podcast, which, as you should know, if you don't know, is the data science industry's most listened to podcast. He's also, and this is just not my opinion, our ratings at ODSC reflect this time and time again. He's also an incredible instructor, incredible speaker, done many workshops at ODSC, and always one of our most highest rated ones. So I waited a long time to say this very short sentence. John, welcome to the show.
It's great to be here. I'm glad to hear that I wasn't one or two of the duds this year.
No, you are not.
That you're upfront about that.
Yeah, well, it's pretty obvious to attendees who they are. Apologies. We spend a lot of time shepherding and reviewing slides and reviewing notebooks. That's where most of my AI knowledge comes from, as you can tell, with large gaps in it. So John, just by way of introduction, I'm sure most of this audience knows you, but give us a little bit of background, what you're at these days, so we can ground this conversation.
Sounds great. So I did a PhD focused on machine learning that I finished in 2012, and that was in England. Came over to New York to work at a hedge fund. So doing high frequency trading using computational techniques, not really machine learning, because the kind of trading that we were doing at this hedge fund was sub-second. And in order to have an algorithm work very rapidly, do this kind of arbitrage between products or cross exchanges that rapidly, it's very simple, very simple computations typically. The more sophisticated machine learning is applicable when you have, if you're looking to be trading and holding for many days or years, then, more advanced machine learning techniques might be more useful more frequently in those kinds of contexts. But so trading, doing that kind of high frequency trading was, it was hard to stay motivated just for money alone, I learned in my case. And so after a couple of years of doing that, I quit and was just living in New York for a few months, enjoying life, when I came across someone who had a job titled data scientist, which I'd never heard before, and was delighted to learn that I was already qualified for this career, that it was in high demand. So this is, we're talking about 2014. At that time, I think data scientists pretty much always were expected to kind of have a PhD, which I think it's great to see that it has broadened. And, obviously it's still an extremely in-demand career, but it was really cool for me at that time to discover it. And I've loved it. I've been a data scientist since I discovered that term. Basically, I've been in love with the career. I was a data scientist at a big corporate in media for a year, and then became chief data scientist at a startup called Untapped in 2015. We were acquired in 2020. And then 2 years ago in 2022, I co-founded a machine learning startup called Nebula that is automating as much as we can of white collar processes. Just being able to automate things in the workplace, and starting with talent acquisition. So using generative AI in particular, as well as encoding AI approaches. So large language models can be used for more than just generating text. We can also be using them to encode information into like a vector space, which I can go into in more detail later on, especially if we get into talking about RAG models later on. So we use LLMs both to encode information to allow quick retrieval, as well as to generate text for our users and save them tons of time and get better results, because they're able to have beautiful custom messages, reach out messages to prospective candidates for a specific role that are in the style of our user. And yeah, it's a powerful thing. I can't imagine we'll be seeing, the kinds of completely impersonal cold reach outs that we're used to getting for, say, data science roles these days, the kind of drip campaigns that, I think that's going to be a thing of the past very soon. And I think we're helping at Nebula make that a thing of the past.
Very, very cool, John. Yeah, fantastic journey. Love to talk more about the high frequency trading and quant finance at some other point, because I think we have that. We do have that in common. But let's get into the topic of today, which is open source training, open source large language models, and deploying in production. Because as you mentioned, you're at Nebula. You guys are leveraging models. You're also doing a lot of great training and instruction around it, as I mentioned earlier. And usually we start these conversations by saying like, okay, what is an open source large language model versus a traditional closed source? But there has been a lot of debate around the meaning of these open source large language models, because as we know, Open Data Science Conference and all these open source communities out there, traditionally with open source software, it was along the lines of, here's the code, we publish a code, and that's it. But with large language models, they're much more complex beasts, right? So, would love to hear your definition of what open source is these days, what it means to be an open source large language models, and where you weigh in the debate, just to get it off to an interesting start.
Yeah, that's very generous of you to say that the reason why things are different with how we're using open source today is related to how much more complicated things are. I think that's being generous. My perception of what's going on here is that you have huge companies like Meta, like Google, who are using proprietary IP that they have developed in-house to create these large language models. They see some benefit to releasing the model weights online. And these benefits include things like, I think it's mostly related to attracting and retaining the best AI engineers. Because when you see something like the Llama 3 post that came out 2 weeks ago, in that Llama 3 post, they're talking a lot about, hey, you know, we trained on 24,000 H100 GPUs. And that's kind of like marketing that allows their recruitment efforts to proceed more rapidly, because people are saying, wow, that's a lot of H100s. I'd love to be doing that. Maybe I should be considering working at Meta instead of my own startup.
Yeah.
And so I think that's a big part of why they release these model weights at all. I also think in Meta's case, because they don't offer LLMs as a service, it allows them to undercut some of the other big tech companies like AWS, like Microsoft with their Azure cloud, Google Cloud. All those cloud providers are leveraging proprietary LLMs, most famously Microsoft, with their huge investment in OpenAI and providing that as a service from Microsoft Azure. And so Meta is kind of undercutting their competitors by saying Llama 3, supposedly the 400 billion parameter Llama 3 model that's still being trained, that one, when it comes out, is possibly going to be comparable to GPT-4. And so that allows them to undercut a competitor while simultaneously getting engineering interest to come join them, because you get to be working at or near the cutting edge. So I think that's, corporations are never doing things out of the goodness of their heart. They're looking for some benefit, and I'm hugely grateful. I am so grateful that there is this scientific community, except for Apple, which publishes almost nothing. All of the other big tech players, they do a commendable job of publishing papers on approaches. They publish data sets, and in the case of LLMs, they publish some model weights. It isn't what we would call, it isn't truly open source, because with something that's open source, we expect first and foremost some code, which is where the open source comes from. And we're not getting code from these big players like Meta or Google when they release Llama or Gemma model weights respectively. We're not even typically getting the most permissive licenses on using those model weights. And that is, again, partly related to competition with big tech companies. So the Llama licenses, for example, forbid you to use the Llama quote unquote open source models like the Llama series if you have more than 700 million monthly active users.
Well, I don't have that problem, John.
I know it basically only applies to the MAMA kinds of companies, Microsoft, Amazon, Meta, and Alphabet. So, formerly what they called FANG, but it always seemed odd to me that Netflix was in there at all. Then we've had a few name changes, like the F becoming an M. Yeah. Anyway, so MAMA. I guess I missed Apple in there. So yeah, Microsoft, Apple, Amazon, Meta, and Alphabet.
Well,
I think those the big.
Yeah, and just to put this in the context of this conversation, and why this is important for our audience is because we have open source rights versus what I would call freely available, which may not be open source, versus ready to use, because that also complicates as well. Because as you mentioned, John, the three things there are like the research and the documentation of how these models work. A lot of times when they release open source, they'll document how they work and give you great insights. That's great. You need that. Second thing is you need the weights, because that's the most important thing. You can go on we'll talk about more about why the weights are important, but you need the weights to actually build your own open source model, train it, fine tune it. You do or do not need the code, I guess. And that kind of comes into that freely available versus ready to use, because some of these open source LLMs are released and they fall into the camp of pseudo open source or fully open source, but not ready to use because of, I don't have 3,000 H100s, which are these advanced chips that John mentioned needed to train these. So we'll plug into that in a little bit, but let's get into now that we've got a broader definition of what we're talking about open source.
Yeah, and I guess
you mentioned. Oh, sorry.
I guess we should also just. I didn't really get to defining it crisply. So when we're talking about quote unquote open source LLMs, what I mean when I say that is model weights that we can go and download somewhere. Maybe we need to get permission from Meta, tick a box to say we don't have more than 700 million users. But one way or another, we get access to those model weights. And so the easiest way to contrast that quote unquote open source LLM situation is to compare it with the completely proprietary LLMs where you don't get access to model weights at all. So something like the GPT, well, since GPT-3, you can't access the model weights. GPT-2, you could. So GPT-2 and beforehand, those are quote unquote open source. GPT-3 and afterward, those are proprietary models. The only way that you can use those models is if you work at OpenAI or if you call an API provider like OpenAI or Microsoft that has access to the model weights. So those are the key differences. Open source, you can download the model weights, even if it isn't truly open source in the sense of having access to their training methodology and their code. And proprietary means you can't access the model weights at all.
Exactly. And proprietary, you're probably paying for it. Open source, it's free to download. So let's get into what do I need to train or fine tune my my open source large language models? So you mentioned weights. Maybe get into that a little bit more. Like, what does that actually mean for people who are not familiar with weights and downloading and what that means in practice and what else I need?
Yeah. So if you're a data scientist listening and you haven't been working with neural networks, so large language models are a kind of machine learning model that uses neural networks, which are a kind of way of modeling information that's been around since the 1950s. The equations of these artificial neural networks are loosely based on our understanding of the way that biological neural networks, brain cells work. And so these neural networks were originally created to allow academics to try to understand the brain better. Now, they're not very good models today of how the brain works, but it turns out that these neural networks are great at learning a very wide range of tasks. It can be demonstrated that if you stack several layers of these artificial neurons together, so at least 5 or more layers, you can approximate any continuous relationship between some input and some output. That can be proved. And there's a great book an ebook by a guy named Michael Nielsen called Neural Networks in Deep Learning, and chapter 4 is dedicated to proving that to you. So you can check that out yourself. There's lots of kind of Java applets there in the web app that allow you to play around with some parameters and prove to yourself that a deep neural network, so deeply layered artificial neurons, allow you to approximate any output given some input, as long as there's some continuous function describing the relationship between that input and that output. And so I just said deeply layered, 5 or more layers of artificial neurons. So that's where the term deep learning comes from. And recently, in 2017, if I'm getting the year exactly right, researchers, it's around there, plus 2017 plus or minus 1. Researchers at Google in a paper called Attention is All You Need. The first author on that paper is Vaswani. And so those researchers at Google came up with a way of organizing the artificial neurons in a deep neural network into something that they called a transformer. And that transformer is designed from the very beginning to scale very well across a large number of GPUs. So, we were talking about the NVIDIA H100s earlier. So you can scale this transformer architecture, this transformer deep neural network configuration very well across a very large number of GPUs. And that transformer architecture has this ability, which is why the paper is called Attention is All You Need. The transformer has this ability to attend to relevant parts of some large document or some image. And so it is kind of human-like in the way, when you think about, if you had a bunch of sentences in a row where it begins with, John was on the ODSC podcast talking about large language models, And then for the next several sentences, it just said he. Until this transformer architecture came out, we struggled with any machine learning approach to be able to track that he back to John several sentences earlier. There was no compute efficient way to do that until the transformer architecture. And so because of that attention mechanism, we can then scale it up to thousands of GPUs in the case of, this 400 million parameter Llama 3 model or GPT-4. And once we scale that up to billions of neural network model parameters, we're able to have a huge amount of nuance where we're not just mapping like he to John, but we end up having a nuanced understanding of the way that the world works encoded in these natural language models. And your question initially, Seamus, was about weights. So basically, an artificial neural network, it has some number of learnable parameters, learnable weights, and a very simple neural network. It operates a lot like a regression model. If people listening to this are familiar with regression models, if you have a regression model that has 3 features that are predicting some outcome. So let's say you're predicting house prices with the number of bedrooms in a house, distance to a school, and how many stories there are in the house. So we have these 3 features that we're using to predict house price. In that case, your regression model has 4 parameters because you have 1 parameter that you learn to figure out how important the number of bedrooms is, distance to a school is, and number of floors in the house is. Plus, you also have an offset, a y-intercept, that allows your average house price to be something that isn't 0. And so that gives the model a lot of flexibility. In the context of a neural network, we would call that 3 weights and the bias. Together, those weights and biases make up the parameters of a neural network. And so very, very simple neural networks might just have a dozen or so of these parameters. But yeah, the biggest, this Llama 3 open source model at the training right now has 400 billion of these parameters because we're taking that transformer architecture, which contains, depending on how many other transformers it's connected to layer by layer, it has some large number of parameters of learnable weights, but then we scale that up to lots and lots of GPUs, and all of a sudden we have billions of these parameters that give large language models all the nuance and capability that allows them to be so powerful. Seamus, I talked for a very long time. Was it more elucidating than complicating?
No, that was hallucinating because I was just searching the SuperDataScience podcast, looking for the episode number with Kirill, because I'm always impressed the way you're on episode number 755.
Yeah, well, that's because I have a spreadsheet.
That's the wrong one.
I have a spreadsheet in front of me, which isn't available to the public.
Because
that
for
allows
folks
me to quickly
looking
look
to
up
learn more about the attention is all you need architecture,
yes.
I would advise them to go to SuperDataScience and check that out.
Yeah, it's actually, so we use the 30-day mark after an episode is published as kind of our benchmark, our key KPI, key performance indicator, our number 1 KPI that we use internally in terms of how an episode is performed is how many downloads and YouTube views an episode had 30 days after publication. And that gives us then, an equal benchmark, because obviously the longer an episode has been out, the more listens it's going to get. So that 30-day point is the point that we say, that gives us some sense of how well an episode did. And this episode, number 747, which you can access very quickly by going to superdatascience.com/747. That episode with Kirill Eremenko is an introduction to large language models, to this transformer architecture, to the attention is all you need paper. And it is our most popular episode of the podcast ever at the 30-day mark.
Nice. 2 quick things. Yeah, I listened to that podcast. Fantastic podcast. 2 quick things. There's a comment here about Apple published 3 papers recently, because I meant to make a comment when you were talking about Apple. It was kind of interesting. There was a very interesting article in the Financial Times, how Apple, can I use the word poaching? Well, the Financial Times uses the word poaching, and they're slowly building up a team of ex-Googlers, because everyone wants a Googler, right? in Zurich and on the West Coast. So they're gearing up. They have to, because they're behind. And Galaxy is pushing hard in AI. And I think there's a new September iPhone coming out in September. And the guy at the phone clerk, I broke my phone at ODSC East. I didn't throw it, I swear. It just fell out of my pocket. And the guy's like, wait till September, it's going to be AI everywhere. I'm like, excellent. You sound like an ODSC conference. Hey, everywhere. So that was interesting. So I expect more from Apple. And it was interesting that around the hiring side. But
at the time of us recording this very episode of your podcast, we had an announcement yesterday from Apple on their Q1 financial results. And while they were slightly down, something like 4% relative to Q1 the preceding year, their stock price went up because that was a lower decline than expected. But also, perhaps reflecting that stock price bounce, is that Apple said that in Q2 of 2024, we will have lots of AI features in the iPhone, in iOS, I suppose, which is interesting, presumably in macOS as well.
Yeah, I got to disagree with you, John. This is a good quant finance question, because we used to see that, like, news will come out and the stock price would do something. And then people say, well, the stock price went up because of this news. Because you saw where Meta came out and they said, we're going to spend a lot more in AI. Their stock price went down 23%. I think it's still recovered. No, I'm only joking, true. But it is interesting trying to make that correlation.
It is. It's very tough to know. There's lots of different pieces of information, and there's different factors, right? It's that, the market might be reacting negatively to Meta saying that they're investing all of this money in open sourcing AI. Maybe that's why, you're like, why are you spending all that money? We as stockholders want you to be putting that money into something proprietary. Exactly. And Apple is. So I don't want to get sure. This is not financial advice, and I am not going to get into the business of. That's actually part of why I was attracted to the high frequency, the sub-second trading, is because it's a fool's game. It's a fool's game to try to pick and hold stocks. Again, not financial advice, but if I were to give you financial advice, it would be to get ETFs that track like the S&P 500 or the FTSE 100, and just hold that till you retire. Don't try to pick stocks, because even people that do it full time all day, focus on your day job, building products, building your own company, increasing your brand value or the value of the assets that you actually have a lot of direct control over. That'll. Well,
I'm definitely one of those people who has to relearn that lesson every month. But so back to and I know you know what that means. Back to the topic at hand here, because we've defined open source. We talked about the weights and the importance of those. So walk us through the fine-tuning process of the process of training via fine-tuning one of these open source models. Because as you said, I can go to Hugging Face, I can go to Meta, I can go wherever, tick a box. I download the weights. I might want to download a tokenizer as well. Walk us through the process of actually doing the fine-tuning now that I picked my open source model.
For sure. So the two key libraries that you need to know about in Python, and I'm not aware of anyone doing this in libraries other than Python, in terms of downloading open source model weights and doing anything with them in your own code, you're going to want to be using Python. And the two key libraries that you need to know about for doing this are the Hugging Face Transformers library and PyTorch Lightning. So the Hugging Face Transformers library allows you to download model weights in the Hugging Face repo. And so this is similar to a GitHub repo where, in GitHub, you have lots of open source code. In Hugging Face, people are constantly uploading model weights. And so when some huge paper comes out about some new transformer approach, you are very likely to have the next day or within the next week, somebody on the Hugging Face team or some other open source developer providing model weights in the Hugging Face ecosystem. And then you can use the Python Hugging Face Transformers library to download those model weights onto your local server. So this could be your laptop, or it could be some Google Cloud or AWS instance that you've spun up. depending on the size of the model that you're downloading. If you're just getting started with this kind of thing, I highly recommend playing around with very small large language models, which sounds like an oxymoron. But so there's models out there like Distilbert, for example, is a small LLM for encoding information, so converting natural language into a vector of numbers, allowing you to search over it, and we can talk about that more in a second. Or if you're interested in generative LLMs, which a lot of people are, generating text or generating code, then a great toy-sized LLM for downloading with the Hugging Face Transformers library to get you started on, say, your own laptop or in Google Colab would be GPT-2. And so once you've downloaded your model weights, then you turn to potentially fine-tuning the LLM to some use case of yours. To do that, you can actually do it in the Hugging Face Transformers library itself. So there's all kinds of tricks to efficiently training LLMs, and I'm just gonna list through these kinds of things, but there's things like gradient accumulation, gradient checkpointing, automatic mixed precision training, dynamic padding, uniform length batching. These are all kinds of techniques that allow you to use less memory and use less compute while you're training your LLM, which it can get quite expensive. So in terms of kind of rough guidelines, when you're working with LLMs, I just talked about a couple of very small LLMs like Distilbert, GPT-2. While those are, you can download those onto your local laptop, but probably if you're playing around, I would recommend something like Google Colab. And we can put a link actually to, I've got a video which I recorded. So I did a screen share while I was presenting on generative AI with large language models last year at ODSC East in Boston. And so I've got a link which we can have in the show notes. Yeah. So yeah, it's generative AI with large language models on my YouTube channel, or I just put the link somewhere here in the platform, so Seamus and the team at ODSC can share that with you all listening out there. And so that is doing it live at ODSC East last year is probably 3.5 hours or something like that. But once, it's cut down to just a little over 2 hours, it's about 2.5 hours long. And we talk through step by step all these kinds of tricks in the Hugging Face Transformers library. The ones I just went through: gradient accumulation, gradient checkpointing, automatic mixed precision training, dynamic padding, uniform length batching. So all those kinds of tricks allowing you to make the most of the resources that you have. But the reason why I'm specifically talking about that training from last year is that we go through Jupyter Notebooks in Google Colab. And one of the cool things about Google Colab is that they give you free access to GPUs, NVIDIA GPUs, or Google GPU equivalents. They're called TPUs, tensor processing units. And with those NVIDIA GPUs or with Google TPUs, I show you in that hands-on training how you can be loading your LLM model weights onto that accelerator, onto that hardware accelerator, that training accelerator, and that allows you to, in real time, with a small data set, a relatively small LLM, to be able to get familiar with fine-tuning yourself. Once you start getting past about 13 billion model parameters, then you might start to need multiple GPUs. And in that kind of scenario, again, the same video link that I've provided and been talking about, this generative AI with large language models training, the final hands-on demos in there, I show you how you can be spreading this training across multiple GPUs. Obviously, that starts to get a bit more expensive. If you're talking about a couple of H100s, you might be talking about hundreds of dollars an hour just to have a couple of those H100s running. But for a lot of use cases, if you're training a 7 billion parameter model, a 13 billion parameter model, you're going to be able to do that on a single GPU. It doesn't need to be an H100. You can do it on, relatively inexpensive GPUs that you can get access to through Google Colab or through other cloud providers for dollars an hour. And I'm mentioning all of this because you can have some, let's say you're fine-tuning a generative AI model. Then you can have some prompt that you think should lead to some desired output that could be based on user behavior in your platform, so it's proprietary to you in some way, or maybe you even hand curated this data set, but for whatever reason you have some set of inputs and outputs that you'd like your LLM to be able to learn to map. Well, you can either in the Hugging Face Transformers library that I've been talking about, or the PyTorch Lightning library, which I highly recommend. You don't need to necessarily be adept in PyTorch itself to use PyTorch Lightning, but what PyTorch Lightning does is it allows you to have even more detail and control over your LLM training relative to the Hugging Face Transformers library. So my recommended workflow is you're using Hugging Face Transformers to download the model weights, and then you're using PyTorch Lightning thereafter, which plays very nicely with the Hugging Face Transformers library, by the way. But you're actually then using the PyTorch Lightning library yourself to do the training. And within that PyTorch Lightning, it is very easy within the frameworks that you build there to do what they call parameter efficient fine tuning, PEFT. And the key thing about PEFT is that it allows you, even on this relatively inexpensive, let's say you have a 13 billion parameter LLM, which can have some pretty nuanced outputs. That 13 billion parameter LLM, you can fine tune it on a single GPU that costs just a few dollars per hour to rent, using the PyTorch Lightning library with PEFT, parameter efficient fine tuning, because what PEFT does, using approaches like, so PEFT describes a range of related approaches, the most famous of which is LoRA, low rank adaptation, LoRA. And what this allows you to do is take that full, say, 13 billion parameter model architecture, that LLM, and you insert in a small number of additional parameters. Maybe it'll be about 0.5% of additional parameters. And all that you do with PEFT is you fine tune that 0.5% extra that you've added in. So the original 13 billion that you download, say the Llama 3 13 billion parameter model that you download from Meta, that stays completely unchanged, which also prevents the LLM from forgetting capabilities that it had, which can happen if you try to tune the whole architecture. So not only is it more efficient to be just fine-tuning this extra 0.5% that you add in, it can actually also have benefits that the model remembers better the tasks that it was originally trained to do, but you can fine-tune the model with PEFT to be specialized to some special task that you have data for. And then, incredibly, this can end up costing you tens or hundreds of dollars total to do this PEFT fine-tuning, but then you have your own proprietary large language model that might outperform a state-of-the-art model like GPT-4 or Claude 3 Opus on that specific task that you fine-tuned your proprietary LLM to be able to tackle. And you might be able to do that with hundreds or thousands of data points only. So lots of super powerful things here. I've been talking for a very long time, but basically the kind of summary point is that with the Hugging Face Transformers library, PyTorch Lightning, a relatively inexpensive GPU rental, we're talking hundreds of dollars total spend, you could take hundreds or thousands of your own data points and use those to create a proprietary LLM that surpasses the absolute state-of-the-art LLMs at some specific task that is relevant to your users or use case.
And yeah, for our listeners who are listening to this podcast, or listening to this recording after we record, this is why John's one of my favorite guests. I can sit back here with my cup of coffee and listen to John give this fantastic explanation and just enjoy my Friday. So John, that was excellent. There's a lot of stuff I want to unpack there, because you, again, as always, you cover so much. But let's talk a little bit about LoRA to help people understand that, because I just remember, for those of you who remember when LLMs came out within the generative AI landscape, and we were looking to fine tune them, back when we were initially trying to fine tune them, it was very inefficient, right? There was, you basically, yeah, if you can talk a little bit about why traditional fine tuning was inefficient, and a little bit more about why LoRa, or low rank adaptation, as you mentioned, why that leads to efficient fine tuning that led to perf, as you mentioned, because if you can talk a little bit more about that specific technique, which I know you covered a little bit, but I think that's super important.
Yeah, for sure. So, and we actually do have an episode of the Super Data Science podcast, of course, that is dedicated to PEFT with LoRa. And so that's episode number 674. You can get that at superdatascience.com/674. And that's a kind of 15-minute introduction to parameter efficient fine tuning PEFT with low rank adaptation, LoRa. And yeah, again, there are some other PEFT techniques. One that got a lot of press about a year ago was QLoRa, quantized LoRa. But the main idea with these techniques, as I said a little bit during my previous response, was that it allows you to take a large language model, all of its model weights, whether that's 13 billion or 70 billion or 400 billion, and then you insert a small percentage of extra model weights, extra parameters, and this could be, yeah, about 0.5% extra. But the training time, like you said, Seamus, if you tried to train an entire LLM, all 13 billion parameters, or oh my goodness, 400 billion parameters,
Yeah,
it would be so expensive and take so long. That's why places like Meta are bragging about having 24,000 H100s to do this training, because that's the kind of scale you need to be training these state-of-the-art LLMs. But you, as a hobbyist or as a data science professional in a startup, you can be using LoRa, like I said, to be training your own proprietary LLM that exceeds GPT-4 or Claude 3 Opus or Google Gemini capability, all those leading proprietary models on some narrow task, having just 1,000 data points for the use case. And in PyTorch Lightning, it's a few lines of code. You can be getting Claude 3 Opus or ChatGPT or whatever to be generating some sample code for you. And I highly recommend that. I personally am constantly using the proprietary generative AI models to help me get my code together. And so you can be doing that yourself. Google Colab now actually has built in, thanks to Gemini, an AI assistant there, just like GitHub Copilot. And so you can pretty easily get that code cranked out to be taking advantage of PEFT LoRa training.
Nice.
In PyTorch Lightning. Yeah,
and I would just say to our listeners, there's so many great tools emerging. When I was playing around with to speed up LLM training was Onslaught. I think it came out at the beginning of the year. I'll add that to the show notes. But I know our listeners are anxious to get on to, okay, sounds great. I've got an idea of how to fine tune a model. Now, how do I get into production? But before we get into production, of course, the most important step is to test and evaluate these models. So you mentioned Lightning AI, you mentioned Hugging Face, but any other tools we can use to test and evaluate these LLMs to ensure, before we put them into production, that they're accurate and reliable?
Yeah, so Seamus, you know these kinds of tools, I think, better than I do, because you have tons of these kinds of companies as sponsors and speakers at ODSC. So, for example, someone that I've met a couple of times now at ODSC East, Amber Roberts, she did an episode with us, Super Data Science episode number 689, focused on these kinds of tools, specifically her company's open source tooling for doing it. I'm blanking. What's the name of that company, Seamus?
Arise.
Arise, exactly. And their open source package is called Phoenix, right?
That's right. Yeah. Arise Phoenix.
Yeah, Arise Phoenix. Very good. I hadn't pieced
I just got that. Maybe that's not the eyes.
Yeah. I mean, another big player, probably the best known name there, is Weights and Biases. which, that ties into earlier I was explaining how the model parameters in a deep neural network, including transformers, including LLMs, is the parameters are made up of weights and biases, and so that's where the name of that company comes from. It's quite clever. And so those are some of the tools out there for out of the box techniques for testing your models. On top of that, I would say that you should be testing your models on the specific task that you fine-tune them to. And in order to do that, a really cool approach, which again, I'll look up the blog post and I'll put it in, I'll provide it to Seamus and the ODSC team to put this in the show notes. But in March of 2023, researchers at Berkeley on the Berkeley AI research team, which is one of the world's leading university research labs, they released a model called Vicuña, which was an open source chat generative model. It took Llama model weights, at that time Llama 1 model weights, and fine-tuned them to a chat use case. And the way that they compared their performance relative to the other state-of-the-art models at that time, which included ChatGPT, the GPT 3.5 model at that time was state-of-the-art. And what they did was they used GPT 4, which had just come out. So GPT 3.5 was, the kind of the state of the art that everyone was using. GPT 4 had just come out that month. And what they did was they used GPT 4 to evaluate, given this input, how did Vicuña, our model, compare relative to GPT 3.5? How did it perform relative to, at that time, Google Bard? And you can ask it to literally provide a score out of 10. And so we use that kind of approach internally to allow us to, because the alternative to that is to have humans, potentially internally, maybe product people or early customers, evaluating, hey, does this output or that output look better? Quite subjective, very difficult to maintain attention to over a large number of cases. But you can allow GPT-4 to work on, some test set that you have of 100 examples or 1,000 examples, and maybe those could be grouped into different kinds of categories of prompts and outputs you were expecting, say, or quality of matches that come back from some embedding some embedding LLM that you used. And so you can use those scores at a 10. You could potentially even have it be more granular, because you could specify, okay, I want an overall score out of 10 for our baseline model versus our fine-tuned model, but also on these particular subcategories, I also want a score out of 10, and those could be things related to ethical questions or some sub-capabilities that are particularly important to you or your users. So that provides you an infinite amount of flexibility, just calling the GPT-4 API, and typically you're going to be able to do that for $10 kind of thing.
Nice. Yeah, John, a lot of things to add to the show notes there. I need a cheat sheet like yours to which episode, but Amanda was also on our podcast. We need to name our episodes. I think it was about
Amber Roberts?
2 months ago. Amber Roberts, talking specifically about Phoenix is one of myself and my team's favorite tools, because we use it for tracing, LLM tracing, looking at what's going on, and also very good for doing those evaluations and embeddings analysis, which you touched upon. And we're actually mostly using it for RAG now as well, which is a good tool. Because I want to get into moving into production, because I know a few of our listeners have questions on that. But should we touch upon RAG a little bit? Do you have time? Yeah,
so we're going to have to go very quickly. We are running out of time here, but there's so retrieval augmented generation, RAG. This is a very powerful technique indeed, and this combines together encoding large language models with generative large language models. So let's say in a use case of what we do at Nebula, we have a natural language document representing 180 million people working in the US. So your professional information, public information that we could find about you
Wow.
online. We combine that all into one natural language document, and then we use a proprietary LLM that we developed to convert each of those 180 million natural language documents into a vector embedding. So what this vector embedding means is it's an array of numbers, an array of float values. What that means is it's like a map describing the location. So for each of those 180 million people, we're able to describe their location in this high dimensional space. So we live in a 3D world, 4D if you include time, but visually you can perceive 3 dimensions. And so you could imagine that for every one of these 180 million people, we have an X, a Y, and a Z coordinate representing the location of that individual in some 3-dimensional space. But computers aren't limited to imagining things in 3 dimensions. You can have any number of dimensions as you want. So let's say, for the sake of making this example straightforward, that we put them into a 100-dimensional space. So this means that for each of those 180 million people, we have a vector of 180 numbers representing the location of that individual in some 100-dimensional space. And so you could imagine this as like a big table with 180 million rows and 100 columns. And then I guess 101th column that's like some ID representing the individual. And what you can do then in real time is someone can come into our platform and say, I'm looking for a data scientist who specializes in PyTorch Lightning and parameter efficient fine tuning. We can take that new string that our user has come into the platform and provided, we can convert that into an embedding in real time using our proprietary LLM that creates a vector of 100 of length 100, and we can see in our database of 180 million rows who are the people that are closest to that natural language input that our user asked for. Who are the data scientists that most clearly exemplified being a data scientist with PyTorch Lightning and PEFT experience, if that's what I said. Yeah. And so we could bring back, say, 10 of those documents, 10 of those people, and then we could provide all of the natural language from those 10 people as the context to a generative AI model. And you could just use, it could be your proprietary LLM that you've developed yourself, or it could be, you could just use GPT-4 from OpenAI. And you provide those 10 documents as well as the original query, and the generative AI model can then give back to you a summary, say, of why these 10 people are a good fit for the original query. So that's an example of this kind of retrieval augmented generation. You're using encoding LLMs together with a generative LLM. And so this allows you to, there's an infinite number of use cases, very fertile ground for automating things or improving things in corporations all around the world. You can imagine a law firm might want to be able to have all of their legal documents, all of their clauses encoded so that they can, a lawyer or a legal clerk who's drafting some contract can say, how do we usually begin a intellectual property clause? Or who is the plaintiff in this case, or whatever kind of natural language question you can imagine. That natural language question can be converted into an encoding. You bring back the most relevant documents from any number of documents out there that the company has, and then you use a generative AI model to answer the original question based on the small number of documents that were pulled back.
Excellent insight in that, John. Really good explanation of RAG. So I think Momin and a few other people are looking for an explanation on, okay, so we have our proof of concept. You actually gave us a great use case example there, which is a real one for your own company. So I want to move now. I want to get into production. And the interesting thing about LLMs versus the traditional machine learning model workflow into production is I could usually serve my model, but then and be somewhat worried about the cost and, of course, monitoring and stuff like that. But with LLMs, everyone's talking about inference costs. So first, can you tell us a little bit about getting from POC into a production environment, and then inference costs and a few other things? And then I got one more question from another user on that, and I think we'll wrap.
Nice. Yeah, so there's lots of different ways that you can deploy into production. We cover a few of those in that same YouTube video, that 2.5-hour long training from ODSC East last year on generative AI with LLMs. So you can check that out. That's those are the last topics that we cover in that video. And so, you can deploy your model weights right to Hugging Face, and then you can use APIs. You can call APIs from Hugging Face, so they're kind of hosting it for you, and you don't even need to be hosting the model weights. Or you can have your own GPUs running in production that are hosting that model. Again, PyTorch Lightning makes it easy for you to do that. When you do put that into production, it can be very expensive. I mean, you're going to need at least one GPU to be doing this with some kind of real-time performance in production. If you're going to have multiple GPUs, then it's going to be very expensive. So something that you might want to do, for example, to save money, if you have a small number of users that are going to be calling the service, then you can actually have a Kubernetes cluster spin up to handle that that generative AI request only when your users request it. And that means that the very first time that they do some generative AI thing in your platform, it's going to take 20, 30 seconds for them to get a result. But then every time after that, it'll be, just a few seconds. So that's potentially a cost-saving way of getting your generative LLM into production.
Yeah, and again, if our listeners don't have a Hugging Face account, I think it's a massive resource that we're mentioning here, and serving that as well. Another thing to think about the interface, because we've pushed a few agents into production, and it's been interesting once they're in production, is thinking about the user interface, because everyone assumes user interface for a LLM in production is just the ChatGPT chat box, but it can get a little bit more sophisticated than that. Like we, like a lot of people, are collecting feedback from that. Sometimes we give more information, what's going on in the agents, what's going on in the tracing. Any advice for the user interface for an LLM in production?
I don't have much guidance on that, no. And I'm afraid I am out of time here.
All right, John, if you are out of time, no worries, because we'll see you at the next ODSC. So people to catch up with you, follow your work, it's pretty easy. SuperDataScience podcast, your YouTube channel, Twitter, LinkedIn. What am I missing?
Yeah, those are the key things. Feel free to connect with me on LinkedIn. If you mention that you heard me on this podcast episode or that we met at ODSC, then I will accept your connection request. Otherwise, you can just follow that LinkedIn account. My social media team takes everything that I put on LinkedIn and repurposes it for Twitter. So if you prefer Twitter over LinkedIn for some reason, then all my posts end up being syndicated over there as well. And yeah, the Super Data Science podcast, 2 episodes every week of the year. We have some of the biggest names in the industry on the show every week. We have a lot of fun filming the episodes. A lot of my guests are people that I meet at ODSC conferences, so I'm grateful to Seamus and the team for that. I also, if there's one way to be 100% sure that you never miss content from me, and the vast majority of the content that I create is available totally for free and truly open source, open source code provided with a very permissive license.
Unless you're 700 million users or less.
Or more.
Or more, yes.
Yeah, the only people that are allowed to access my code are Google, Meta, and Alphabet. Alphabet, Meta, and Amazon. The most permissive license, like in Apache 2.0 on all my code. And So I have an email newsletter. I try to send it once a month. It always ends up being a little bit longer than that. But that is the 100% sure way to ensure that you don't miss any of my content or any of my upcoming talks at ODSC or wherever else. And so you can register for my newsletter at johnkrohn.com. There's the biggest thing on that page, the most prominent thing is the email newsletter sign up.
John, you are certainly a very busy man. So that's why I really appreciate you taking the time to come on the podcast and give us pretty much what I could say was a pretty thorough education on open source LLMs, from fine tuning and getting into production. So apologies to all the questions we didn't get to. We might have to have you back for part 2 at some time in the future, given your availability and copious, not free time. So John, thank you again. Thanks for being a speaker at ODSC. Thanks for coming to the podcast, and hopefully we'll see you at ODSC Europe or ODSC West or someplace in the near future. Love to have you again.
Yeah, my pleasure, Seamus. Thank you very much for inviting me on the program and the great questions, and I look forward to seeing you again soon. Thanks, everyone, for listening.
Thank you, John. And all right, everyone, that's a wrap, and we will see you again next week. Goodbye for now.